In one of the previous videos, we have looked at a Python library called Pandas AI, which brings LLM and chat capabilities to Pandas data frames. That library is quite good. In this video, we are going to look at similar capability from Llama-Index. Now, Llama-Index, it's a framework for building generative AI applications. They have the tools, agents, query engines, etc. Right? So using the Pandas query engine from Llama-Index, it gives access to this larger ecosystem of agents and tools. So we can have more capabilities, like we can combine the data from Pandas with data from, let's say, the databases, PDF files, etc. And we can enable agents to reason. So we can do many more things. Okay. So it's a simple pip install. And then from Llama-Index, import Pandas query engine. Okay. And then from IPython, this is just for displaying. Okay. Here we are reading a simple 1000 records data from IMDb movies. Okay. It's a regular data frame, which you must have seen before. So it's about the top 1000 movies from IMDb. All right. And then we instantiate the query engine using the Pandas query engine. We simply supply the data frame. Now enable this verbose to true so that we can see the code, etc. Okay. And once we have the query engine, we can chat, we can ask questions to the data frame. Right. All right. So here query engine dot query, and here we are asking the question, what is the correlation between number of votes and ratings? Okay. So here it is also showing the code. Now Pandas AI, it does not show the code. So this is looking right. So it is taking the number of votes column from the data frame. It is applying this correlation function and with IMDb rating. Okay. All right. So as you can imagine, our description should reasonably match with the columns in the data frame. For example, if we have some anonymized column like V1, V2, V3, etc., then it won't be able to answer like this, right? So it should be able to understand using natural language. That's looking good. So the code is looking right. And here it has computed the correlation function. Don't worry about this one. So the response, it's of type response, and the response contains the actual answer, and then metadata contains the code. Okay. So here we are just displaying the response using this markdown in bold. Okay. And then this pandas instruction string, it contains the code which is actually generated first before computing the answer or results, right? Now I asked the same question using one of the variables which is not of type int. For example, I asked it using which one is it? I think runtime, because it is of type object. It threw an error saying it cannot compute. I'll show you an example of that as well. Okay. And then here we are asking another question, list columns with missing values and the number of missing values. Okay. And then we have another instruction, only show missing values columns. Okay. Now it has applied this is null function and then computed the sum of how many are missing. To that extent, it did well, but it has ignored this instruction, only show missing values column, because there are several columns which does not have any missing values. So only the certificate, the meta score, and the grass columns have some missing values. So it did well, but it has ignored this instruction. All right. And then here we are asking, what are the 5 longest duration movies? Okay. So it has identified, it should look into the runtime variable. And even I am not aware of this function n largest. it's good. It came up with this function n largest. We wanted 5, and it should be looking for runtime in order to answer this question. So that's looking good. And okay, so here is the thing. Now, since this runtime variable, it is an object, it is an type object because we have this string min. It is unable to compute because it is saying the runtime data type is of type object, not some int or float. Okay. And then what are the top 5 rated movies? So we are asking exactly the same question, but using a different variable because this is float. It is same code except a different variable. This time it is able to answer correctly. All right. And then let's ask a little more trickier questions. So what is the average duration of movies? So see here, it's not properly framed sentence, but let's say if it understand it. Okay. What is the average duration of movies released in 2000? So there is one filter and have a score greater than 8. So it should apply 2 filters before computing the average. So let's see the code. So it said looking for release year, which is equal to 2000. So that is looking good. And then the score, see here we have set score, and in this data frame, we have only one variable which has score in its name. So it said meta score greater than 8. Now it is looking at runtime, but notice this time runtime is a object, not an integer variable. But this time it is able to extract the float value from runtime. So as you can see from here, runtime, it has this minutes, right? 142 minutes, 175 minutes, etc. But it is able to extract the integer part of it, see, and converted that to int, and then computed the mean value. So as you know, these LLMs, they don't always expect the way they don't always behave the way we expect. For example, in this case, it is able to convert this object to int, whereas here it said it cannot do that. Okay, it's the same runtime variable, but it said, hey, this is an object of type object, so I'm unable to get you the top 5 movies. All right. So be careful in mind, it always don't give the consistent results because as you can see here, it is of type object, but yeah. And then we can even generate plots. So here we are saying visualize a bar chart of number of movies each year. So before doing the plot, it has to compute the average, the number of movies each year. So let's see what it is doing. So here it is saying evaluate, that's looking good. So release year, value counts, and sort by index. So the index is year here. So it is going from low to high values, and then doing a plot of kind bar. So it is looking nice because we have too many years. Now let's see, let's add one more filter. So here visualize same question, but here we are saying the movies after 2000. Okay, so the year after 2000. So it's first applying this filter before computing the number of movies but for each year and then plotting. Okay, so this is looking good. Here we have this variable, I mean the value PG, which is incorrect, but for some reason it's showing here. So as you notice, it is doing reasonably well job. For example, for this data type conversions, etc., we can use agents which can reason, which can convert the data types before doing the computations. But again, be mindful, the results are not always consistent. Despite that, these LLMs are very helpful in understanding these numerical type of data sets. just using natural language. Okay, that's all for this video. Thank you very much.